In this screencast, just want to cover a couple aspects of Newton's first law for those times when forces are in equilibrium and our object is not moving. Examples of that would be, say, the Golden Gate Bridge. We certainly don't want that moving, or perhaps someone just sitting around in a tree. We can look at Newton's law either that our forces are balanced, therefore motion stays the same, and we're taking the special case right now of not moving, or an object is not moving and therefore the forces must be balanced, meeting Newton's first law. Let's look at the case where the forces are balanced. Okay, here we have an elephant standing on the ground. I've separated out the earth here just so that we can identify what component is coming from gravity. Okay. I can see that the weight of my the weight of my elephant is 50,000 newtons. Give you an idea, that's about 10,000 pounds, or about 5 tons. So that's being pulled down. Okay, why isn't the elephant plunging to the center of the earth? That's right, that the floor of the ground is pushing up with 50,000 newtons of force as well. Okay, what we see now is that the object is the forces on the object, our elephant, are balanced. We have 50,000 newtons down, 50,000 newtons up. The net force, we saw that in the reading, net force in this case is equal to 0. Do it again. Is equal to 0. So as noted here, if the forces are balanced, then the object will not change its motion. We'll assume our elephant is standing still. Okay, because forces are balanced, it will continue to stand still. So if our initial velocity or speed is equal to 0, then our final speed is also equal to 0. Remember, unbalanced forces are needed to create changes in motion. Now let's take a look at another case where we have an object that's definitely not moving and see how Newton's first law applies to that. Okay. So now we have a condition where the velocity does not change. If the velocity is equal to 0 and it's staying 0, okay, then what we know about the system is that the forces must be balanced. This is the other way we can read Newton's first law. If the velocity doesn't change, then the forces must be balanced. Or if the forces are balanced, then the velocity must not change. Let's look at the case here. We have our donkey or mule. Okay, we have the earth down here. There is certainly a force of gravity downward, and from the ground we see that there is an upward force called our normal force from the ground. We can see that someone's trying to pull this horse or this mule to the right, but it's got its hooves dug in, so there must be a frictional force to the left. If you want to give an idea what these forces, this would probably be a gravitational force. Here, this would be some type of a normal force, a tension force to this direction, and a frictional force here. All right, hope that helps out. Enjoy.